Okay, I have to make a video today about names and formulas for molecular compounds. And that's because my last video, the sound didn't work, so you wouldn't be able to hear anything. So we've been learning this week about molecular compounds, compounds that are made up of all nonmetals, all right? And now we want to learn how to name them, all right? So let's talk first a little bit about the properties of molecular substances. Remember, we're talking about all of those compounds that are made up of all nonmetals, all of those atoms on the right-hand side. And unfortunately, I don't have a video that displays the properties of molecular substances. I'm hoping that we can do a lab when we get back to see them for real. But I did a little demonstration when we were talking about ionic compounds, and I'm going to just add to the side here just a reminder of what ionic compounds did when we tested them. Excuse me. And you don't have to write that down on the side. It's just it's just to remind us of what we saw. So molecular substances, they tend to be soft, all right? And a good example of a molecular substance is wax, all right? And you know that you can take wax and squish it in your fingers, and it's very, very soft substances. Just to remind us, ionic compounds are very hard, all right? You can't do that with a grain of salt. You can't squish a grain of salt because their crystals are way too hard. Again, molecular substances have low melting points. Again, if we're talking about wax, it just takes a little bit of a flame to melt wax. And ionic compounds have a very high melting point. I don't know if you recall, I put a little bit of salt in a deflagrating spoon, and that salt did not melt even in the hottest part of the flame. Molecular substances, they do not conduct electricity as a solid, and that's because their electrons are locked into their bonds. The electrons can't move freely. When it comes to ionic compounds, they also do not conduct when they're in the solid state, and that's because their ions are locked into place. Their ions cannot move freely. When we dissolve a molecular substance, they stay as non-conductors. Again, their electrons are locked into their bonds. They can't go anywhere. But when we dissolve an ionic compound, yes, it does conduct electricity. And again, that's because their ions now can move around, and that can conduct the electricity. In terms of their solubility, some molecular substances can dissolve, like sugar. Sugar is an example of a molecular substance, and some does not dissolve so well, and that's like wax or different types of oils. They do not dissolve, and that's the same for ionic. Some ionic compounds dissolve really well, and some do not. Okay, all right. So those are the properties. Like I said, hopefully we can do a little lab when we get back. All right. So naming molecular substances is actually quite easy. We use something called the prefix method. And so we put little words in front of our elements to tell us how many of those atoms there are. So the prefix is attached to the name of each element in the compound, indicating the number of atoms of that particular substance. Excuse me. If I'm going too fast, pause the video so that you can write down the note. So an example of this, and we know this, is a chemical that looks like this, CO2. And we know what this chemical is. We've seen this before. This is called carbon dioxide. And the di represents the fact that there are two atoms of oxygen in this particular substance. Just to compare it to the ionic compound Al2O3. Remember, we get this formula by crossing over the charges. And this ionic compound, again made from a metal ion and a non-metal ion stuck together, is simply called aluminum. Oops, there's a little bit of a spelling mistake. Aluminum oxide. And notice we don't put di's and tries in front of it. All right, so that's different. That's what we learned before. Okay, so we're going to use these prefixes to tell us how many atoms there are. So let's write down what the prefixes are. Okay, so again, take the time to maybe pause the video and write down these prefixes so you have them in your notes. Again, 1 is mono, 2 is di, 3 is tri. That makes good sense. 4 is tetra. That's a tricky one. Tetra simply means 4. All right. And 5 is penta, like a pentagon. 6 is hexa, like a hexagon. Hepta and octa. All right. And those last ones are a little easier because we learned them in geometry a little bit. Again, pause the video if you need some time to write this down. Okay, so a couple of rules. It turns out that we only use mono on the second atom if we need it. If the first atom, all right, is only 1, we don't put it in. We've already seen an example of this. By the way, this is just my Zoom screen, so it makes it writing a little easier. CO2. We've seen this guy. This is called carbon dioxide. Notice it's not called monocarbon dioxide, even though carbon has only 1. And that's just I think historical. I think the naming system just didn't put mono at the front to represent 1, and so we still don't do that. So if there's only 1 at the front, we don't put a mono. Okay. And the second thing we have to watch for is if we have compounds that contain hydrogen, we do not use this method. And that's because hydrogen compounds are special. All right, let me give you an example. H2SO4. If we have a chemical that starts with H, all right, starts with H, this is what we call an acid. And acids are special. Acids behave a little bit like ionic compounds. So we treat their names as ionic compounds. So this is not called dihydrogen sulfate. It's just called hydrogen sulfate. All right? So we don't use the prefix method for acids. And we will learn more about acids later on. Okay. Let's do some examples here. So, using our prefixes. You might have that in your note nearby. That's a good thing to do. We've already seen this guy. This is a classic. Carbon, no thing at the front here, right? So it doesn't. So that's, again, just 1. Di, that's 2. CO2. As easy as it gets. No crossing over for this. Just as straightforward as it can be. Phosphorus, just by itself, that's a 1. Trichloride, that's a 3. PCl3. I suggest that you write down the examples. All right, pause the video, write down the examples, and then try them, and then come back and check. All right, that's the best way to do that. That's the only way you know whether you know how to do this stuff. Okay, so pause, write it down, and then give them a try. Okay, let's try the other ones. Dinitrogen, pentoxide, no crossing over, N2O5. All right, straightforward. Hydrogen selenide. This is an acid. How do I know it's an acid? Starts with, get out of the way, starts with hydrogen. Okay, which means we're going to use the good old crossover for this. H, Se. If you take a look at Se, it's under oxygen. It's a -2 charge. Hydrogen's a +1 charge. So we're going to cross them over, and that's going to put the 2 here and the 1 there, but we don't write in the 1, so that's hydrogen selenide. All right, and like I said, we'll be doing acids later on. Okay. Again, As I stated, good practice would be to write this down, give it a try, all right, and then check as I put the answers up. So do that. Pause the video, give them a shot, and then we'll check them. Okay, I'm hoping you've done that. So 1 sulfur. Remember, we don't start with mono. 3 oxygens. Sulfur trioxide. Sulfur trioxide. Again, no mono on the front. 2 nitrogens. 4 hydrogens. Notice the hydrogen is on the back here. That's different than this acid here. By the way, this next guy is an acid, so we don't use the prefixes. This guy, the H is on the end. This is on the back. All right? So it's not an acid. So we will name it using our proper method. 2 and 4. Dinitrogen. 4. Tetroxide. Tetroxide. We don't put tetraoxide because 2 vowels in a row becomes tough to say. So we say tetroxide. If you were to make that little mistake, I wouldn't care. No prefixes. Hydrogen. You might think monobromide, but because it's an acid, simply bromide. Bromide. Hydrogen bromide. It is an acid. 2 chlorines. 1 oxygen. Dichlorine monoxide. All right. Again, we don't put monooxide. That's kind of a tongue twister. So we just put monoxide. Okay. Pretty straightforward business. One last thing before I let you work on a worksheet. There are several molecules that are very common. Again, write this down. And I need you to know the names of these common molecules. So our first one here is classic water. If I say water, I need you to know what that is. Okay? H2O. The second one, NH3. That's a chemical called ammonia. All right? It is a gas. It's a very stinky gas. All right? You might have smelt it in things like glass cleaner. All right? Ammonia is that pungent smell that comes from sometimes manure. All right? You get that pungent smell of ammonia when there's manure that's been sitting around a lot and decomposing. All right? Another important one, O3. Notice it's not O2. O2 is the oxygen we breathe in the air, but O3 is ozone. It protects us up in the ozone layer from ultraviolet light. And the last one that I need you to know, CH4, is called methane. Methane is a flammable gas. It is the main component of what we call natural gas. And we use natural gas in our Bunsen burners. And natural gas burns very well. We use that as a fuel. All right? So, at this point, you can go ahead and you can try some of the naming sheets from the molecular naming system. All right? Excellent.